Welcome to the Mipar tutorial on FFT filtering. So in this tutorial we are going to view three applications of FFT filtering, and they will be the first, which is perhaps the most common use, which is to get rid of low frequency intensity variations in the image, so-called high-pass filtering. The second will be to remove curtains in a dual beam fib serial section dataset, or to minimize them. And the third will be so-called spot filtering to enhance the clarity of a high-resolution atomic lattice image. So let's start by opening up the image processor and get started with the first application. And we will go and grab our image. Now under pre-processing you have apply FFT filter. On the left you're seeing the FFT of the image, and on the right its current filtered state, which is none at the moment. So for a high-pass filter, we're going to use the ideal high pass, and the sigma will affect the size of the filter, and you'll see what that looks like. So you type in a value, you click generate, and now the white indicates the frequencies that are erased. So what's happened, if you consider what an FFT is, the lower frequencies in the image, the more gradual intensity transitions, are going to be towards the center of the FFT, and the higher frequency values, which are the more abrupt intensity transitions, are out towards the edges of the FFT. So if you run a high-pass filter, what you're doing is you're allowing the higher frequencies to pass, and therefore discarding some of the lower frequencies. If we invert this filter and say we're going to use a low-pass filter of the same sigma value, now we're keeping those lower frequencies and discarding the rest. So what we've done is effectively a blur operation by running a low-pass filter. So it takes some time to get accustomed to what frequencies mean in image space. You don't necessarily have to know that for all of your applications, but typically if we're trying to get rid of variations in the image, like channeling contrast variations, where the different particles have different intensities based on their crystal orientation, a high-pass filter can be a nice way of doing that. And the higher you make your sigma value, the more severe your filter. And what you're doing now is just you're discarding more and more of the low frequencies, and your higher frequencies, which are really your edges, are getting accentuated over the lower frequencies more and more. So you end up with this sort of flat appearing grayscale image where all of the information that remains is really at your edges. Now you can do all sorts of other filters here. Cutoff, which is just a circle mask to keep or discard. Annular, which puts a disk in your FFT. Usually I stay with ideal filters. They reduce the artifacts compared to cutoff. If you need to keep a select range of frequencies, that's where your annular would come in. And down here are your custom filtering tools, where you can draw right on the FFT and remove and keep frequencies in that fashion. We'll show that here in the next example. So let's open up the second application here, which is going to be getting rid of curtains in a dual beam fib serial section slice. What's happened here is your ion beam has come down parallel to the image and sliced away a bit of material, but it's left these milling artifacts, these, we call them curtains, these this artificial roughness now that exists on the surface, and that can make processing these images quite challenging. So the FFT, an FFT filter can be a pretty effective tool here. Again, we'll go into apply FFT filter, and And what we're seeing here is a great many frequencies that lie along this orientation. So what does that mean? Well, if you consider the origin of the FFT, and you pick a frequency now out here, the vector that connects those two points along the direction that that intensity transition occurs in the image. So it's no surprise that we see a lot of frequencies on the x-axis because our curtains are oriented vertically. So all of our high and low, we have a lot of high and low intensity transitions that are occurring in the horizontal direction. Hence, all of our or many of our frequencies are lying along the horizontal. And in fact, I think since the curtains aren't perfectly vertical, actually most of your curtain frequencies are lying along this slightly off horizontal band. So what we can do is erase those frequencies, skip the very middle, since that has low frequencies from all orientations in the image. We want to try to keep the very center of the FFT, so we're going to erase these bands that indicate or that that capture the curtains. So to do that, we can, let's zoom out here, we're going to choose our line tool. I'm just going to do a quick test here and draw a line and say erase, just so I see what my pen size is looking like. 1 is obviously far too thin. Let me undo that, zoom in here. Let's bump this up to 8 and just draw a test line here. Erase those frequencies. That's a pretty good thickness then. So we'll undo that, we'll come back out, and now I'm going to take and I'm going to draw a line along this orientation. I can adjust it once it's drawn. Let me zoom out here all the way out. Let me continue this. Oh, I guess that doesn't quite work that way. We'll make sure to fix that. Idiosyncrasy in the one of the next releases. So we'll draw our line along that direction. We'll say erase, and now we'll go ahead and invert this, or mirror it rather, over the origin, erase. So now we're gonna erase on that side. And you can see what we've done, we've started to minimize the influence of those curtains. Now they're not completely gone, but they're certainly less severe. We can also add another line here. Now we'll say mirror origin again, erase. And now you see the curtains are strongly reduced. So we've gone from this to that. It's almost magical sometimes when it works that well. It's just quite surprising what you can accomplish with image processing. You almost can recover intensity that you thought wasn't ever captured. So that's going to make finding those laths, those features, much more interesting, or much easier. Okay, so there's a second application, and the last one will be some spot filtering here on a high resolution atomic lattice image, where you have to be careful with this filter and definitely disclose in any publication that you include the results of it in that this is what you've done, because there are certain cases where you don't really want to be doing this. But for some applications, it can definitely be helpful to bring out some atomic lattice that was otherwise unclear. So under our pre-processing again, we'll go to FFT filter. Now what you're looking at is basically a diffraction pattern of this image. So if we go and we, again, test out our pen size here, we're going to use the circle click tool. I'm just going to double click on a point and say keep that to see the size of the circle that we're going to be drawing. And we'll bump that up maybe to 30 just to include a little bit more area. So I just need to pick the points in one hemisphere. So I'm going to say circle click, and I'm going to click really on any maxima that I see here in the FFT. So I'm really just keeping what I think are all of the frequencies that correspond to atomic positions. Press enter. You can adjust any of those if you need to. We'll say keep. And again, now we'll do a mirror over the origin, and we'll say keep again. So what we've done is we've basically filtered out the background intensity that is not corresponding to atomic positions. Now again, I said be careful because what you are doing is basically forcing a certain periodicity to appear in your image because you've selected those spots intentionally. But if you know that the structure is there and you don't care, and you're really just trying to suppress background noise, then this can be a helpful technique in some cases. If you want to see, and I think, let me undo that. I need to do mirror origin keep. I think I did erase before. There we go. So if you want to see what we've done, we've gone from this to this. Now if you want to see the information you've removed, if you do invert, when you invert the mask, now this is all of the information that you've removed. Because in this case you're just keeping everything but the spots. If you toggle the preview on and off, you can see you've gone from that to that. So really just background intensity modulations have been removed. And scan noise. So that's another application of FFT filtering. That should do it for this tutorial. Thanks very much for your attention. Let me know of any questions, and I'll see you in the next one.